Welcome back, everyone. We are in chapter number 1, CCNA second semester, chapter number 1 from Networking Academy. And welcome back, all my students, again, who are having to stay home, including myself, all in lockdown and shelter in place. So we are missing our class. So now this is our way to explain the chapter, study together. I hope that this video is going to definitely help all my students that are in my college and class. Also, whoever in general public will watch, if you're doing CCNA, and if you're a beginner, it's going to really help you out to study the chapter. So let's go over again. This is where we left in the part 1, and let's see, part 1, that's where we left in this screen. So here we were discussing the administrative distances. When a route in a router is a path for data to travel from a source to a destination. In the routing table, there are many entries, many lines, many routes are written in the routing table. On each route, there is a number, there is a letter in the very beginning. It says how this route was learned. And each type of route, depending on how it was learned, whether it was a directly connected route, whether it's a manually written down route, or learned by some routing protocols, based on that, it has an administrative distance, it has a value, it has its reliability. And that's what we're discussing. So if the route is learned because that particular network, destination network, is directly connected to my router, then my router will say this is the most reliable, it's directly connected. If it is manually written, if that network administrator guy manually wrote down a route, then that one has administrative distance of 1, and so on. If it is learned by EIGRP, then administrative distance of 90. If it is by RIP, 120. OSPF, that will be 110. These ones definitely I wanted to learn, as I mentioned at the end of my part 1 video. So let's move on from here. Okay, these ones I want you to do the practice at home. Just check how router makes the forwarding decision. Practice that. I will move on from here. Otherwise, we will not be able to discuss all of it. Okay, let's see. We're just drag and drop. That's what we're doing. We have some protocols here, or how the route was learned. The route source is written. Say a particular route, a particular path was learned via RIP protocol. RIP protocol told the router that, hey, this is the best way to go to that route. What kind of administrative distance, what kind of value, what kind of reliability that route would have. So RIP 120, so we put it in here. A static route is written down manually by the network administrator. He's a human, he wrote down a line that's very reliable, so its value is 1. Okay. Now EIGRP, that's Enhanced Interior Gateway Routing Protocol. That one would be 90. Its value is 90. It's denoted by D, the letter D. OSPF is written by the letter O, and it's 110 is its administrative distance. If a route is learned because that destination network is literally directly connected to this router, one of the ports of this router, then that is the best route for sure, because the router says that destination, you don't have to go through any other router, it is directly connected to me. So that one is the best one. So administrative distance of 0, the most reliable route. Okay, and then you have the external BGP. External BGP, I don't remember myself on that one. So let me see which one that would be. Probably 100, probably 170. I don't know. This one I don't know myself. So I'm gonna just check it and see. No, that one did not work. So probably it's gonna be 100, 115, one of those. Most likely 100, I guess. Yeah, so it has to be 100. These ones you typically don't memorize, but you memorize, no, nothing, maybe then 5 external BGP right here, maybe then 20, my lord, so it's 20. Yeah, so I want you to memorize these ones. These are very well known. External BGP is not also covered in our chapter. In our we're not going to be discussing these things yet. So, but they just put it in here. So definitely you want to memorize the earlier ones. Let's move on to the next. The routing table. That is very, very important. Okay, we're going to see what a routing table looks like. Let me show you. I go to the Google and I go to the pictures. First, I want to show you what a routing table looks like. Routing table in a Cisco router, because routing table in a PC looks different from what it looks like in a Cisco router. This is what a routing table would look like. Okay, and let's see. If I look at it here, okay, let's see. This is what a routing table looks like. So much is written, but it's very, very simple. This S meaning it's a static route. C means directly connected. L means local interface. So how do we read these things? Very simple. Let's look at this particular route. This one is a static route. 00000, meaning all network. That means every network. Via 209, that is the IP address of the next hop router. Serial 001, that is the exit interface of my router. This is directly connected serial 001. Okay, so look at that. This is a default route, and this one is its administrative distance is 1 because it's manually, it's a static route. Okay, to go to any network, any other network that is not written in this routing table, all other network in the world that I do not, that is unknown to this router, for those destination, router is going to send this packet to this other router, 209.165.200.234. That's the next hop, the next router. This router's gateway router. And to go to this route, it has to go through this serial interface. That router is connected to my serial interface 001. That's what it says. Now look at this route right here. C. C means directly connected. So nobody wrote this one. Router already knows it because it's directly connected. What network? 172.16.1.0 with a 24-bit mask. This particular network is directly connected. And to go into that network, the packet has to exit through gigabit Ethernet 00. That's what it means. So any network that has to go to this particular, any packet that has to go to this particular network, it has to go out of this router via gigabit 00, because that network is connected to the gigabit 00 interface. L. L means not a network, it's a local interface. That's why it's an IP address, not a network address. 172.16.1.1, 32-bit mask. That's one single IP address, as opposed to the upper line, the first line with a C, that one is a .0. That is not an IP address, that's a network address. This one denotes a whole network, and this one denotes just one IP address. That IP address is that gigabit Ethernet's IP address. That's what it means. L means local interface. This another route right here. These two lines, look at this one. R, this route was learned by RIP protocol. To go to this network, if since it's learned by RIP protocol, its administrative distance is 120 via 209.165.200. So that is the next hop address. It has to go to this router. To go to that in network, my router is going to send the packet to this IP address. That's my next hop router. This timing 000012, that's the timestamp. My router has learned about this route 12 minutes ago. Okay. And then serial interface, it has to go exit through this interface to go to that router. Okay. So that's the routing table I showed you in the Google. Okay. Go back to where I was. Let's see if I can exit close. Alt F4 maybe. Okay. That takes me out, and then go back to where I was. Okay. Okay. Now let's go back to the next slide. Okay. Routing table of R1. Here is a router. R1. That router shows a routing table, and it also shows. See, the routing table is right here, down here, and the very top. This is a little bit explanation information for you. That shows L means local, C means connected, S means static, R means RIP. These kind of things will be always there. How did you find out this output? In the router, in the privileged executive mode, we type this command, show IP route. That's how you display routing table. And then it's going to show like this information, and then at the end, there are two lines here. That line shows this 10.1.1.0 with a 24-bit mask, that destination network. That network was learned by D means EIGRP. It was learned by EIGRP protocol. Therefore, its administrative distance is 90. This 217011 to this long big number, that is called the matrix. It's just a value. Okay, it is not administrative distance. It's just a value that computer automatically computes based on other factors. So its administrative distance is 90. To go to that network, you have to go via this other router. That's the next router, 209.165.200.226. And it has been learned for this long time. It has to go through serial interface 000. That's it. So let's move on. Okay. Now, the same thing that we just discussed is showing here, that what these mean. The first, this letter, that means how this route was learned. This was learned by EIGRP protocol in this case. This is the destination network. This is the administrative distance. This is the matrix. Via, that is the next hop router. This is the timestamp, time duration. Right? And this is the exit interface. To go to that network, the data packet has to go out through serial 000 interface. In this case, right here, serial 000. Okay, let's move on. Okay, now it is asking you to put those items in the right place. So we already know every routing entry. See right here, routing table entry. It starts with the source, how this route was learned, like O or D or C or L or S. In this case, okay, if I am going to go for this one, say learned by D, then it has to be like that. Okay, that means it's learned by EIGRP. Okay, then what is the destination address? The destination address, say right here, 209. That's the destination address. Okay, and let's use this one, remote network, 10.1.1.0. That's the destination address. That's a far away network. That's not directly connected. If it's directly connected, then it's something else. Okay, Now in this case, we have the administrative distance of D would be 90 because it's EIGRP protocol. D means EIGRP protocol. And then via what? Via this network, this router. To go to 10.1.1.0, if you see my mouse right here, I have to go through from my R1 router, I have to go to this router first. What is this router's IP address? This dot 226, that one. So dot 226, that one, via that. How long the time has passed? Well, this is the how much time has passed per se. And what interface do I have to go out? S000. That's the interface I have to go through to go to that router. So S000, I put it in here, like that. S000. Then I do check, all good. So we're all good. Okay. So if I give enough time and just do this for you, and sometimes, but most of the activities I want you to, I'm not going to do it for you. I'll keep it for you so at home you can practice, practice, practice. And as you know, no worries. If you did a mistake, you just click on check. You did a mistake, then you reset and do it again. That's how you learn. So I'm going to mostly leave it for you to save time and the actual explaining the chapter. Okay. Now directly connected interface, we understand that. Directly connected routing table entries, that always going to start with C and L. C means connected, L means local interface. So just to quickly to tell you what it is in this case, here is my R1, that's a router. This particular network 192.168.10.0, that network is directly connected to this router 00 interface, gigabit 00 interface. Okay, therefore that destination network would have a C, means connected, directly connected to it. See, and this gigabit 00, its IP address is what? .1. So here's the .1. That's its IP address. Okay, that's the local interface. That's it. Simple as that. That's it. That's a very simple entry in the routing table. That's not a remote network. Okay, directly connected examples. We move on to that. Same concept. Now the same thing, directly connected, but IPv6. Same thing. Okay, same thing. This time I'm using IPv6 address as opposed to IPv4 address. So what I have right here is, that is the network right here, 2001 colon 0db8 colon ACAD colon 1. Then at the end, all this colon means what? All zeros. So that's a network address, not one single IP. It's the whole network. 64-bit, 64-bit network ID and 64-bit host ID. So that whole network is connected to where? To this gigabit 00 interface. And it will be colon 1. At the end, instead of colon, it's going to be colon. At the end will be 1. One more 1 in here, right? So, right here. That is the address for this gigabit 00. Okay? All the way 1 and then 1. This is one interface. So that's how you configure IPv6. Packet tracer. Static route. When you manually write down a route, that's called a static route. You use a command. Okay. So we already know that if the network, if a destination network is directly connected, then route, I don't have to write anything. Router automatically is going to write down in the routing table with a C, means connected. We already saw that. Now say you being a network administrator, you want to write manually, type up one entry in the routing table. That's called the static route. That's what we're discussing right now. Static route. Okay. So static route and default static route. Okay. How do I write? What is the command to write such a static entry? Here is the command. command is IP route, and then the network, and then the mask, next hop, or exit interface. And we're going to see the example in a minute. What is a default route? A default route means an IP address, the network address will be 0000, subnet mask is 0000. Okay, if I magnify it, you can see it better. Okay, that's called a default route. All zeros, meaning every network in the world. So if there's in my routing table, my router only knows a few routes, and all other routes in the world my router does not know. So what my router is going to do for those destination networks, my router says, I don't know how to send, where to send. I don't know every network in the world. So that's why I would write down this static route entry, this default route. So what's going to happen? My router is going to say now that, oh, okay, any route that I don't know, I know where to send. I'm going to be sending it to this next hop, this next router of mine. If I do not know any route, then I'm going to send it to this next router to mine. He knows what to do after that. Okay, that's called the default route, and we're going to see examples of it, I'm sure, in the next screen somewhere. Okay, so here is a default route example. IP default route. Look at this. Let's try to understand it. Here is my R1 router. I have local network. This one 192.168.10.0, 192.168.11.0. These two are my local network that I'm connecting. But then through the internet, through the WAN connection, there are other networks in the world that I know of. Okay. Now, if somebody is sending a data, some packet to this network, then I know where to send because they are connected to me. If somebody wants to go, if a packet comes to me and that has to be sent to a far away network, many other network in the world that I don't know, what do I do with that? So R1 says, well, for that, all I'm going to pass it to my next router. My next router, he is going to be my default route because I know these two other way, this way is a dead end, is my local network. There's no other world in this side. This way is another dead end. I don't go to the world through this way. To go to the outside world, I have to go this way. So that's why this router here, R2, is my default route. I'm going to have a default route. That's my next hop router. So what I wrote, look at the command. IP route 0000, 0000, meaning all network and every network in the world, go out through serial 000. So here's my serial 000 interface. So any route that I don't know in the world, I'm going to throw it to this router. That's what it means. Okay. Now, move on. Okay. Same way, static route can be written for the IPv6 as well. All I have to do, the command is a little bit different. Same kind of command. This command says IPv6 route. But hey, where's my 0000? Remember in the v6, colon means all zeros. Colon means all zeros. And /0 means 0-bit network ID. That means all network in the world. Everything's zero, everything's zero. That's what, this is the way to write in IPv6 for all zeros. That's my default route. So in this case, I'm using IPv6. So I'm saying that the default route is going to have to go out through serial 000, meaning the rest of the world is not this way. This way is my own home, my own little network. And this other way, from serial port, is the whole world, wide world is open here. Okay, so that's my default route. So that's what I wrote. So serial 000, that's what I have to go out through. That's the serial 000. That's exit interface. Okay. The same thing, probably more practice and all those things. I'm not going to go over every single thing. So let's go to the next concept. So that was static routing. What I discussed, that I can manually write down, the command is IP route, or for the v6, the command is IPv6 route. Okay, either IP route or IPv6 route, one or the other. That's my command. And what is dynamic route then? Now it says dynamic routing scenario. What is dynamic routing? Well, dynamic routing means you are not going to write down manually all the routes in the world. No, you cannot do that. Can router automatically learn many other routes? Yes. How? Via routing protocols like OSPF, like RIP. So in your router, you're going to run RIP protocol. And this router here also running RIP protocol or OSPF protocol, EIGRP protocol. So those protocols, what they do, routers talk to each other and say, hey, I know a route and I'm going to share that with you. And you know a route, let's share, let's talk. So those are the dynamic, meaning automatic. You don't have to manually write it down. Okay, so that's called dynamic routing. Now let's see what we're talking about. How do we configure the dynamic routing? Okay, an example right here. So there is a command called router command. After this command, if you do a question mark, then you see what are the protocols, routing protocols available for me to configure BGP, EIGRP, ISIS, ISO, IGRP, all of this. Okay, the most common is this EIGRP, OSPF, and RIP. These are the three most common ones that we'll be using. In this chapter, in this course, we're going to be only using probably RIP, maybe a little bit of OSPF. So now, these are some protocols that you're going to be learning about in here. Okay. IPv4 dynamic routing. Okay. Not. Okay, IPv6 routing protocols. Okay. On the IPv6, you have these routing protocols: EIGRP, OSPF, RIP. That's it for now. For the IPv6 dynamic routing example, I'm sure we're gonna be doing it whatever chapter we can actually configure RIP. I'm trying to see whether it's here or not. Okay. Okay. This one shows very interesting. Look, what is showing in this one? Route print is a command, and that's in my C prompt. So route print is a command that shows the routing table in my computer. Let's try to use that. So I'm gonna go here. Go to my command prompt. Here's my command prompt, my DOS prompt in my computer. I'm gonna type R. Okay, first of all, I'm gonna go a little bit more up so you can see the screen better. Or I could just type, okay, CLS, that means clear screen. All the screen is clear now. Then I will be typing route print, PRINT, see, routing table in my computer. Look, IPv4 route table. Every PC has a routing table, and PC's routing table look different from what a router's routing table looks like. Okay, it's totally different. But every PC, my PC and your PC, also has some routing tables. They also have routing tables. IPv6 route table is there also. PCs learn some routes and they keep them in their routing table. Okay. So now that's what it shows right here. Okay, that's it. We're done with the chapter. So chapter 1, concepts, we are done. So then we're going to be going for chapter 2 another day, and from this point on I'm going to send you an announcement, and I'm going to announcement of course is going to go by email to you also. I'm planning to do this live class session on every Monday and Wednesday, 2 days, just 2 days, Monday and Wednesday. I'll probably start at 9 o'clock, and I'm going to go on maybe now looks like more than 2 hours, because I'm going to be discussing the chapter. I'll try to make it in hour and a half. The chapter will be discussed, let's say 2 hours with breaks and everything, and then we come back. So I'm going to give you a break now. just to be prepared, we're going to do our first lab today. So get the lab done with me together as you always have done in the class. I would feel bad to just leave you in the ocean by yourself and say that, well, all the class is in the online, do it by yourself. So I'm going to go ahead and do the lab. And the today's lab will be the very first lab that is assigned for us. And that lab is 1.1.2.9. Okay. In our lab assignment, that lab, we're going to be doing it. So I'm giving you about some time. Let's see, right now it's 10:46. Let's take a good half an hour break. Let's come back at 11:30 and just do one lab today. Okay, and slowly we're gonna do how we're gonna be doing it. We do need to do 2 labs a day and 1 chapter. That's really ideally we need to do. So let's take a break for right now. Our chapter is done, and we're gonna come back and do the lab session again at 11:30. Okay, I'll see you at 11:30, every one of you, at that time. Okay.